everyone, we're going to sketch the curve whose parametric equations are given, show the orientation, and identify the requested point. We're going to justify our point by analyzing the appropriate derivative. We have t is in the interval of 1.5 to 4.5. So what I did is I went ahead and evaluated some of these points. And it's helpful if we write this in rectangular equation or Cartesian equation, and notice that y equals cosine of 2t, and the double angle for cosine is going to be 1 minus 2 sine squared of t. Since we have 2 sine here, we can write this as y equals 1 minus x squared, or you can say I'll put up here y equals negative x squared plus 1. So this is a parabola that opens down. The vertical shift is at 1. It shifts at 1. So since we already know what this looks like, this is going to help us because it's kind of hard to guess and check which to choose here. So I went ahead and chose 1.5, 2.5, 3.5, 4.5, and I also chose pi. So I did this one last. This is pi. This should go right into this level right here. So if you graph this, we're going to go, this is your x and your y, the ordered pair here. So x is about 1.2, then we're right about at negative 1, close to negative 1. So we're just going to estimate it. It says sketch. All right, and then that's our starting point. Then at 2.5 we have 1.19, and that's going to about a fourth. So that's about right there. So it's kind of going like that. And we're starting here, so your orientation is up this way. And then of course at 3.14 it's at 0.1. Now coming back down at negative 0.70, we're at 7.5. So we're back, I just kind of make it symmetric to what we had before. So let's just kind of make it symmetric and have it. But it sure helps, it's supposed to be kind of curvy. Again, your orientation is going this way. So you keep going around like this. Alright, and it's supposed to be curvy. Alright, sorry for the back graph. It's supposed to be a sketch anyway. But it sure helps that we wrote it like this first, so we know what it looks like. In fact, alright, so anyway, I don't like how this looks, but I want to change it so bad. So basically it comes down here, and this is your orientation. Alright, so there's your graph. Now we have to justify our highest point, which is your maximum, and that's at 0.1 by taking the derivative. Since it's the y, we're talking about the highest point, we're going to differentiate y. So what we're going to do is maximize y as a function of t by computing derivative of y with respect to t. Now that's going to equal negative 2 sine of 2t. Now on the number line, we're going from 1.5 to 4.5. And again, we were at pi here, or 3.14. Now between 1.5 and pi, this is going to be positive. That means our graph is increasing. At pi is the turning point or the critical number. And then from pi to 4.5, it's decreasing it. You get negative. So there's a relative maximum at t equals pi, where x comma y equals 0.1. Thank you. Have a nice day. Bye-bye.